morning, all of you. In this session, I am going to explain about ladder friction. This is the example diagram for ladder friction. You can observe. In this session, I will explain how to draw free body diagram for ladder friction problems. Okay, this is the example diagram. Okay, this is a free body diagram for this condition. Okay, these are the different forces acting on the ladder. In this session, I will explain how to determine ladder friction. Ladder friction. Here you can observe. This is a ladder. Here. Now this is a vertical wall. This is a floor, horizontal floor. Okay. Here in this diagram, you can observe this is a vertical wall and this is a horizontal floor. Okay. Due to self weight of the ladder, or when man stands on the ladder, the upper end of the upper end of the ladder tends to slip downwards. Okay, due to the self weight of the ladder, or man or when man stands on the ladder, the upper end of the ladder tends to slip downwards. Okay, hence the force of friction between the ladder and the vertical wall, will be acting upward. Okay, in similar way, the lower end of the ladder will tends to move towards right. Okay, towards right. Hence, a force of friction between the ladder and the floor will be acting towards left. Okay, this is ladder can be analyzed by applying conditions for equilibrium of non-concurrent force systems. If a ladder is placed against a rough horizontal floor and a rough vertical wall, smooth or roughly, then the ladder is subject to the non-concurrent force system. Okay. So here in this case, you can observe due to the self weight of this man or self weight of ladder. Okay, the upper end of the ladder tends to slip downwards. Okay, due to self weight of a man or self weight of a ladder. Okay, this ladder, the upper end of the ladder tends to slip downwards. Okay, hence the friction between the ladder and vertical wall. Here, this is a vertical wall. So the friction between the ladder and vertical wall, F2 equal to mu 2 R2, will be acting upwards. Okay, upwards as shown in figure. Okay. In similar way, the lower end of the ladder will tends to move towards right. Okay, move towards right, and hence a force of friction between the ladder and floor, F1 equal to mu1 R1, will be acting towards left. Okay. Now, from this diagram, you can observe this is a vertical wall. Okay, and this is a horizontal floor. Now, AB is a ladder. Okay, AC is a floor, BC is a vertical wall, and here AB is a ladder, length of a ladder. Okay, so this ladder makes an angle theta with respect to the floor. Okay, so this ladder makes an angle theta with the horizontal floor. Okay, here the self weight of a ladder, always acts at the center of the ladder, at the centroid of the ladder. Okay, self weight of a ladder always acts at centroid of the ladder. That means half of the length of the ladder. Okay, so self weight of a ladder always acts at mid span of the ladder. Okay, midpoint of the ladder, a point at which entire area of the body assumed to be concentrated is called centroid. Okay, here the centroid lies here. Okay, that means half of the length from bottom and the top. Okay, so at the centroid of the ladder, the self weight of a ladder always acts at centroid. Okay, now this is the position of a person from top x distance. Okay, now due to the self weight of a ladder and the self weight of a person, the reaction force will be induced at point A and at point B, because here point A and B are the contact points with respect to the floor and wall. Okay, at, at point of contact, you have to consider reaction force. Okay, already we know that at point of contact, you have to consider normal reaction forces. Okay, here there is a contact between the lower end of the ladder and the floor, so you have to consider a normal reaction. Here the floor is horizontal, so you have to consider vertical reaction force. Okay, here the ladder is, sorry, this support or floor, horizontal floor. So this is a horizontal floor, so you have to consider perpendicular reaction force. Okay, that means this reaction force makes an angle 90 degrees with respect to the horizontal floor. Okay, now R2 is the reaction force between the top of the ladder and vertical wall. Okay, here the wall is vertical, so you have to consider horizontal reaction force. Reaction force always makes an angle 90 degrees with respect to the support. Okay, here the support is vertical, so you have to consider horizontal reaction. Okay, WL is the self weight of a ladder, WP is the self weight of a person. Okay, now here R1 is the reaction force between the ladder and the floor, R2 is the reaction force between the vertical wall and ladder. Okay, and x is the distance, position of the person from top of the ladder. Okay, now here this is the direction of motion of the ladder. Okay, so when this ladder moves downward, then the direction of motion of the lower end is like this, so you have to consider opposite frictional force. You have to consider horizontal frictional force in left side direction. Okay, always frictional force opposite to the direction of motion. Okay, so you have to consider opposite frictional force. Okay, here R1 is the normal reaction, F1 is the frictional force. F1 equal to mu1 R1. Mu1 is the coefficient of friction. Mu1 is the coefficient of friction between the ladder and the floor. Okay, mu1 is the coefficient of friction between the ladder and the floor. Okay, in similar way, this ladder moves downward, so the direction of motion of the ladder is downward, so you have to consider opposite frictional force at point B. Okay, so here this is the direction of a frictional force. Okay, so here the direction of motion of the block is direction of motion of a ladder is downward. So you have to consider upward frictional force. Okay. Now you can observe there are 6 forces, 2 reaction forces, 2 frictional forces, and 2 self weights. Total 6 forces. Okay, there are 6 forces acting on the ladder. Okay, you have to resolve these 6 forces to determine the unknown values. Okay. Okay. Here R1 is the normal reaction force between the ladder and the floor. R here F1 equal to mu1 R1 is the frictional force between the ladder and floor. R2 is the reaction force between the vertical wall and the ladder. F2 equal to mu2 R2 is the frictional force between the wall, vertical wall and ladder. Mu1 is the coefficient of friction between the ladder and the floor. Mu2 is the coefficient of friction between the vertical wall and ladder. Okay, mu equal to 0 for smooth surfaces. For smooth surfaces, you have to consider 0 coefficient of friction. Okay, there is no friction between the smooth surfaces. Okay, mu not equal to 0 for rough surfaces. For rough surfaces, you have to consider coefficient of friction. Okay, this is very important for solving the problems. We have to consider these 2 cases. Okay, here AB is the length of a ladder. Okay, and WL is the self weight of a ladder, and WP is the weight of a person or weight of a man. For determining the position or for determining the unknown values, you have to resolve all the forces along the horizontal axis and along the vertical axis, and sum of all moments with respect to the any point of the equilibrium at any point. Sum of all moments about any point A or B or C. Okay. For determine the moments, you have to use some fundamentals. These are the important fundamentals for determining the moment of force. Okay, here already we know that moment of force is the product of line of action of the force and the distance between the line of action of force and point of rotation. Okay, so in this case, yeah, this is a turning point. Yeah, this is a horizontal supporting rod. When a vertical load is acting on the rod at a distance of d from the turning point, then the rotation like this. Okay, this is the position. This is the possible rotation. Okay, here in this case you can observe this is a clockwise rotation. Okay, for clockwise rotation you have to consider negative sign. Okay, for clockwise direction you have to consider negative sign. Okay, here you can observe this is a clockwise direction. In same way, in this condition you can observe if the load is acting upward direction, then the direction of motion of this rod is like this. This is anti-clockwise rotation. It moves in anti-clockwise direction. So for anti-clockwise direction, you have to consider positive sign. Okay. For anti-clockwise direction, you have to consider positive sign. Okay. Now we have to observe this case. In this case, this is the position of the given rod. Okay. Here, this is the direction of a load. Okay, when the load is acting on the rod, then the direction of this rod like this. Here you can observe this is the clockwise clockwise movement. Okay, you can observe this one. For clockwise direction, you have to consider negative sign. Okay, this one and this one both are clockwise direction, so you have to consider negative sign for these two cases. Now you have to observe this case. Okay, here this is a rod and this is a force. When this force acting left side, then the direction of motion of this rod is like this. Okay, this is the rotation. This is a anti-clockwise. This is a anti-clockwise direction. For anti-clockwise direction, you have to consider positive sign. Okay, positive sign. For a clockwise direction, you have to consider negative sign. Okay, so these are the important fundamentals. For resolving the forces along the horizontal x-axis, then you have to consider positive sign. For right side direction, for left side direction, you have to consider negative sign. Okay, now for resolving the forces along the vertical axis, then you have to consider positive sign. For upward action, downward action, you have to consider negative sign. Okay, these are the important sign conversions. Okay, now for clockwise movement, you have to consider negative sign. Okay, for anti-clockwise movement, you have to consider positive sign. Okay, by using these sign conversions, you have to determine the unknown values. Okay, now this is a given problem. A uniform ladder of length 10 meters and weighing 20 newtons is placed against a smooth vertical wall with its lower end 8 meters from the wall. In this position, the ladder is just to slip. Determine the coefficient of friction between the ladder and floor, frictional force between the ladder and floor. Okay, this is the question from the given question. First of all, you have to identify the position. First of all, you have to draw a diagram. Okay, so here this is a vertical wall BC. Okay, BC is a vertical wall and AC is a horizontal floor. Okay, here AB is a ladder. Okay, AB is a ladder. L equal 10 meters is the length of the ladder. Okay, L equal to 10 meters is the length of the ladder. Okay, and also here the self weight of the ladder also is given, that is WL. WL is the self weight of a ladder. WL equal to 20 newtons. Okay, so WL equal to 20 newtons and the length of the ladder L equal to 10 meters. And the position of this ladder also given. Okay, the lower end A and the vertical wall. The distance between vertical wall and lower end is 8 meters. Okay, this is here AC equal to 8 meters. Now the height of vertical wall is not given. You have to determine that value. Okay, now the angle of inclination of the ladder also is not given. You have to determine that value also. Here you have to observe a uniform ladder of length 10 meters and weighing 20 newtons is placed against a smooth vertical wall. That means here this wall is a smooth surface. Okay, this wall, vertical wall, having a smooth surface. So you have to consider zero friction. Okay. So for smooth surfaces, you have to consider coefficient of friction equal to 0 and friction force also 0 for smooth surfaces. Here, this horizontal floor is a rough surface. So you have to consider coefficient of friction for this floor. Okay. So in this case, the vertical wall is smooth. Okay, the vertical wall is smooth. So you don't consider friction. Don't consider friction for smooth surfaces. Okay, that one is very important condition. The given values are length of the self weight of a ladder WL equal 20 newtons and length of a ladder AB equal to L equal to 10 meters and distance of lower end of the ladder from wall equal to AC equal to 8 meters. Coefficient of friction between the floor and the ladder. Here this is a floor, so the coefficient of friction between the ladder and the floor is mu1. Okay, you have to determine that value. Okay, in case 1 you have to determine coefficient of friction between the ladder and floor. Okay, that is mu1. And in second case you have to determine friction force between the ladder and the floor. Okay, that is F1 equal mu1 R1. Okay, these two are the unknowns we have to determine in this problem. Now here for vertical wall, you have to consider zero coefficient of friction because this surface is smooth. For smooth surfaces you have to consider zero coefficient of friction, and also the friction force also zero for smooth surfaces. Okay, because here when you are substituting the values mu t equal 0 in this equation, automatically friction force equal 0. For smooth surfaces mu equal 0. Okay, for rough surfaces mu is not equal to 0. Mu value always lies between 0 to 1. Okay, there is no units for coefficient of friction. From the triangle ABC, you have to determine the value of angle theta. Okay, angle of inclination of the ladder with respect to the floor, that is theta. Okay, from triangle ABC, cos theta equal to adjacent side divided by hypotenuse side. Here the adjacent side is AC divided by hypotenuse equal to AB. Okay, so cos theta equal to AC by AB. Okay, here AC equal to 8 meters, AB equal to 10 meters. Okay, so the value cos theta equal to 0.8. Okay, theta equal to cos inverse of 0.8 equal to 36.86 degrees. Okay, the angle of inclination of the ladder with respect to floor is 36.86 degrees. Okay, now here from triangle ABC, sin theta equal to opposite side BC by hypotenuse. Okay, BC by AB. Okay, sin theta equal to BC by AB. Okay, from this condition you have to determine the height of a vertical wall BC. Okay, BC equal to here sin theta equal to opposite side by hypotenuse. Here the opposite side is BC, hypotenuse is AB. Okay, from this equation you have to determine the value of BC. Okay, BC equal to sin theta into AB. Okay, here AB is the length of a ladder, so L into sin theta. L into sin theta is the value of height of a wall, height of a vertical wall. Height of a vertical wall BC equal to length of a ladder into sin theta. Okay, so here the theta value is 36.86 degrees. You have to substitute that value. L equal to 10 meters. From these two values you can get the value of height of a vertical wall BC equal to 6 meters. Okay, now you have to consider freeboard diagram. This is a ladder AB. Okay, and here theta is the angle of inclination of the ladder with respect to floor. WL equal to 20 newtons is the self weight of a ladder. Okay, from the given question, the self weight of a ladder WL equal to 20 newtons. Okay, and here already we know that self weight of a ladder always acts at the midpoint of the ladder. Okay, that means half of the length from bottom, half of the length from top. Okay, so this is the position of a ladder self weight. Okay, self weight of a ladder. Now you have to consider reaction forces. Okay, here at contact surfaces you have to consider reaction forces. So this is a reaction force at point A and this is a reaction force at point B. Okay, here the support is vertical, so you have to consider horizontal reaction. Here the support is horizontal, so you have to consider vertical reaction. Okay, after that you have to consider direction of motion of the ladder. Okay, here this bottom edge will move right direction, so you have to consider left side frictional force. Okay, in similar way, this is the direction of motion of the upper end of the ladder. Okay, then you have to consider opposite frictional force. Okay, this is the direction of a frictional force. Okay, d dash. Now mu1 is the coefficient of friction between the floor and the ladder. Mu f1 equal to mu1 r1 is the frictional force between the ladder and floor, and mu2 is the coefficient of friction between the ladder and vertical wall. Okay, at point B, that f2 is the friction force between vertical wall and ladder. F2 equal to mu2 r2. Here that value equal to 0 because this is a smooth surface. Okay, vertical wall having smooth surface, so you have to consider 0 friction and 0 coefficient of friction. Okay, mu equal to 0 for smooth surfaces. Okay, now resolve all the forces along the y-axis. So here r1 and f2 and WL, these three are the vertical forces. Okay, R1, F2 and WL, these three are the vertical forces. You have to consider these three forces. Okay, for upward direction you have to consider positive side, for downward direction you have to consider negative side. Here R1 plus R1 minus WL plus mu2 R2. Okay, these three are the vertical forces. Okay, consider equilibrium condition. Okay, now from this equation, R1 equal to WL plus 0. Here the value of mu2 equal to 0. Okay, for smooth surfaces you have to consider mu2 equal to 0. Okay, so from this equation, reaction force R1 equal to WL equal to self weight of the ladder equal to 20 newtons. Okay, now we have to resolve all the forces along the horizontal axis. Okay, F1 and R2, these two are the horizontal forces. Okay, so you have to consider these two forces. For left side direction you have to consider minus sign, for right side direction you have to consider positive side. So plus R2 minus mu1 R1 equal to 0. Okay, from this equation R2 equal to mu1 R1. Now you have to substitute the value of R1 in this equation. So mu R2 equal to 20 into mu1. Here the value of mu1 is not given, you have to determine that value. For determining the value of mu, you have to consider moment of forces at point A. Okay, for determining the value of coefficient of friction you have to consider okay, for determining the value of coefficient of friction mu1 you have to consider moment of forces about point A. Okay, in that case, for determining the moment of forces, first of all you have to calculate the length of AD dash, AD dash. Okay, from triangle ADD dash. Okay, the length of AD dash equal to AD into cos theta. Okay, cos theta equal to adjacent side AD dash divided by AD. Okay, from that relation, the length of AD dash equal to AD into cos theta. Okay, AD equal to 5 meters. Okay, L equal 10, 10 by 2 equal 5 meters. So AD equal 5 meters, AD equal 5 meters, and cos theta, theta equal 36.86. So 5 into cos 36.86 degrees equal to 4 meters. Okay, after getting the length of AD dash, you have to consider moment of forces about point A. Okay, you have to consider moment of forces about point A or about point B. Here I consider moment of forces about point A. Okay, already we know that moment of force equal to force into perpendicular distance between the line of action of force and the turning point. That is, here I consider this point A as turning point. So you have to consider moments. For clockwise direction, you have to consider negative sign. For anti-clockwise direction, you have to consider positive sign. Okay, here the fraction, yeah, mu1 r1 into zero distance, r1 into zero distance. Here these two are the forces acting at a point A, so there is no perpendicular distance. Okay, so you have to consider 0 as perpendicular distance. After that, WL, okay, WL into perpendicular distance. Here the perpendicular distance is AD dash. AD dash equal to 4 meters. Okay, now you have to consider R2 and F2 forces. Okay, this mu2 R2, okay, passes through point C and B. So the perpendicular distance between F2 force and point A is AC. Okay, AC is the perpendicular distance between the point A and force mu2 R2. Okay, mu2 R2 into AC distance. Now R2, the distance, the perpendicular distance between R2 and point A is BC. Okay, BC is the perpendicular distance between the force R2 and point A. Okay, now for clockwise direction, you have to consider negative sign. For anti-clockwise direction, you have to consider positive sign. Okay, from this equation, you have to substitute all values in this equation. We can get the value of reaction force R2. R2 equal to 13.33 newtons. After getting the reaction force, you have to substitute this R2 value in this equation. Okay, you have to substitute this R2 value in this equation. Now you will get the value of coefficient of friction mu1. Mu1 equal to R2 by 20. R2 equal to 13.33 divided by 20 equal to 0.67. This is the value of coefficient of friction between the floor and ladder. Okay, after getting the coefficient of friction, you have to determine frictional force F1 equal to mu1 R1. Okay, frictional force between the ladder and floor is F1. F1 equal to mu1 R1. Substitute the value of mu1 and R1 in this equation. Here R1 equal to 20 newtons and mu1 equal to 0.67. Okay, so frictional force between ladder and floor is 13.33 newtons. Okay, this is the value of frictional force between ladder and floor. Okay, so this is the final answer for this problem. Okay, in next class I will explain more problems on ladder friction. Okay.